So in this video, we're going to talk about arithmetic series. And so let's start with this problem. Add up the numbers 1 to 100. So you could just do 1 plus 2 plus 3 plus 4 all the way up to 100, but that's going to take some time and we want to figure out a quicker way. So there's a bunch of different ways to do it, but one of the more common ones, this is the way a famous mathematician, Gauss, did it. He was in like, I don't know, second grade or something. He was annoying. The teacher said, hey, go up, add the numbers 1 to 100. That'll keep you busy for a while. And he thinks about it for 2 seconds. He's like, oh, it's 5,050. And he annoyed the teacher more. So here's what he did. He took 1 plus 100 and he said that's 101. Then he said 2 plus 99, also 101. 3 plus 98, also 101. 4 plus 97, 101. And so he said, well, how many 101s am I going to have? Well, in the middle, you're going to have 50 plus 51, and that'll be your last pair. And so how many pairs were there? There were 50 of them. So it'd be 101 times 50, and that is 5,050. And so this is kind of the method he came up with. They call it the Gaussian method. Um, and we're going to kind of use this for the next couple examples. So what if we add up 1 to 1,000? Well, it's the same kind of idea. We're going to go 1 plus 1,000 is 1,001. 2 plus 999 is 1,001. 3 plus 998, 4 plus 997. And then in the middle, we're going to have 500 plus 501. So we would have 500 101s. So if we multiply that by 500, we get 500,500. Okay, so these are both arithmetic series. They start at 1, they go up by 1, and then the first one went up to 100, this one goes up to 1,000. Would it work for this series? So if we start at 17, go up by 4 each time, and then end at 61. Well, 17 plus 61, that's 78. And then when we jump up 1, that's adding 4. When we go down 1, that's subtracting 4. And so those kind of balance each other out, and that's also 78, 78, 78, 78, and 78. So how many 78s do we have? We have 6 of them. And so it'd be 78 times 6. I'll grab my little calculator off screen, and we get 468. So what's different about this one is our multiplier is times 6. On the previous ones, it was times the middle number. So why is this not times, 39? Because that would be the middle, basically. Well, the reason why is we're talking about how many pairs there are. So if there were 12 terms here, so 12 terms. So if there's 12 terms, there's going to be 6 pairs. And so you add up the first and the last, and then multiply it by how many pairs. So in terms of our formula, if we came up with a general rule for this, what we did is we took the first term and we added the last term. We added those two together, that's why I put it in parentheses. And then we multiplied it by the number of terms divided by 2. So that's half of it because there's that many pairs. So in a more mathy way, the way we write this is Sn, this means the sum, that's why they use capital S. The first term, what we've been talking about, is A1. The last term is AN, that means whatever is going to be your final one there. Number of terms is N, and then divided by 2. So this is kind of our arithmetic series formula. Anytime you have an arithmetic sequence that you're adding up, that's called a series. And so anytime you have an arithmetic series, you can use this formula to quickly find how much those would all add up to, rather than typing all of them into your calculator. So let's try it on these couple. We have 20 terms. Well, let's write it out. I'll do it in words first. So first plus last times the number of terms divided by 2. All right, do we know any of these? Well, the first one is 7, so that's good. We don't know the last. It's not 31. That's the fourth term. We got to figure out what that last term is. Do we know the number of terms? Yep, there's 20 of them. They said how much will the first 20 terms add up to? So to figure out the last term, what we're going to do is just use our arithmetic sequence formula. So to figure out the last term, we take the first one, add the difference times n minus 1. So for the 20th term, we take our first one, and our difference, it's going up by 8, it looks like. And then since this is the 20th term, we're going to multiply by 19. So 7 plus 8 times 19 is 159. So we're going to add these two together. We get 166 times 10. And so that'd be 1,660. So if you add up the first 20 terms, where you start with 7 and you go up by 8, it's going to add up to 1,660. So maybe try the next one, see if you can do that one. It's really the same problem, it's just there's 30 terms. Um, and you know, see if you can get it. I'd pause it and try it on your own. So what I would do is I would take the first term plus, we don't know the last term, times 30 divided by 2. To figure out that 30th term, we're going to take 2 plus, this is going up by 5, it looks like, and then times 29. So 2 plus 5 times 29, I get 147. And so I'm going to add 2 to that and then multiply by 15 because that's half of 30, and I get 2235. All right, and then the last couple here. Let's look at this one. This is in sigma notation. If you remember what this means is we're going to plug in 4 for n, and we get that answer. Then we plug in 5, and then we plug in 6, then we plug in 7, then we plug in 8, 9, 10, all the way up to 34, and then we stop. Well, that's going to be a lot of terms. And so we want to figure out um, how to do this in a more efficient manner. Well, our formula, not A, is A1 plus AN times n over 2. So it's first plus last times the number of things divided by 2. Let's see, the first one, well, we're going to plug in 4. So if I plug in 4 to this, it'd be 240 minus 15 times 4 minus 1. And so when I do that, I get 195. And then to get the last term, I'm going to plug in 34 because that would be my last one I would do. We do 240 minus 15 times 34 minus 1. I'm going to need a calculator for this one. 240 minus 15 times 33. I get, oh, I did the wrong one. I'm like, what am I doing? Times 33. There we go, negative 255. I just typed in times 3, not 33. All right, and then n is not 34. It's not 30. Those are kind of two most common guesses. So what would n be? It's not 4. So if we start at 4, and then we plug in 5, and then we plug in 6, and then we plug in 7, all the way up to 34, how many times are we plugging in there? Well, the way I always think about it is, what if it was just going up to, instead of 34, what if it was going up to 6? So I'd plug in 4, and then I'd plug in 5, and then I'd plug in 6. So plug in 4, plug in 5, plug in 6. That's 3 terms. But from 4 to 6, that's only a difference of 2, right? 6 minus 4 is 2. So it's always going to be one more than if you subtract the top and the bottom. So what is going to go up top here is going to be 34 minus 4 plus 1. So that would be 31. So that's how you're going to do it anytime you have a sigma, where you're going to subtract the top and the bottom and then add 1 onto that. Okay, and so then the sum, we would just take 195 plus negative 255 I'm going to hit enter on my calculator, and then I'm going to multiply by 31 divided by 2. And I get negative 930. Okay, try the last one. I believe that's 931. So do the kind of the same thing we did there, and you should get 931. All right, that's it.